Hello friends, uh, welcome back to the module of statistical analysis for research. In last video we have seen about or learned about descriptive statistics. In this video we are going to learn some of the fundamentals which is very essential to know about inferential statistics. So let's start learning about the key terminologies of inferential statistics. The first and foremost two terminologies which we often come across while testing the hypothesis or maybe using other kind of inferential statistics is parameter and statistic. So what is the difference between parameter versus statistic? So as we have learned in the previous video that there are so many descriptive measures like mean, median, standard deviation, then again skewness and correlation. So the descriptive measure which we use for the population is called parameter, and it generally denotes in the Greek letter. Same way, the descriptive measure which we use for the sample is called statistic, and generally we denote it in a Roman letter. For example, when we say mean, we can also symbol the mean with the help of mu, and same way we can also denote mean with the help of x bar. But the basic difference is like when we say mu, it denotes population parameter, and when we say x bar, it denotes sample mean. So this is just give you a better idea that mu, that means population means, sigma, that means population standard deviation, capital P means population proportion, and capital N, which is sample size. This all are called population parameters. And X bar, S, P cap, and N will be called sample statistics. So this is the first difference and two terminologies which we across going to use in the inferential statistics, parameter with statistic. Now, what is the relationship between parameter and statistic? So in the process of inferential statistics, we generally select the sample, calculate a sample statistics. In this case, we have calculated X bar and use this sample statistic to estimate population parameter. That means mu, right? So we can utilize sample statistic to estimate about population parameter, and this is called process of inferential statistics. That means to infer about the population parameter from sample statistics. So now I hope that you are clear about the process of inferential statistics. Now let's move and learn some more fundamentals. Generally, when we talk about the inferential statistics, we often refer to the hypothesis. We came across the term called hypothesis. Now, what do we mean by hypothesis? Yes, generally the first word comes to our mind is assumption. That's true. So hypothesis, just a minute. So hypothesis is basically an assumption or a tentative statement about the relationship between two or more variables. That means the old beliefs, certain assumptions which researcher want to either prove wrong or he want to establish a new assumption or new belief to the respondents, for which that particular to prove or disapprove the claim is to undertake some experiment or a study. So once a researcher has some assumption in a mind or a tentative statement, or he came across theory which he want to test, then he frames a statement which is called research hypothesis. So a research hypothesis is nothing but a statement of what the researcher believes will be the outcome of an experiment or a study. So that will be again in a raw form or maybe in a language which cannot be tested statistically. So once researchers have a clear picture in a mind that what particular study he want to carry ahead and what hypothesis he has in mind, then he further need to go and reframe it as a statistical hypothesis. Now, when we say that statistical hypothesis, it is a more formal structure derived from the research hypothesis, and it has generally two parts. One is called a null hypothesis, which says that nothing new is happening. That means all beliefs is true and all theories are true. If a researcher want to prove that no, all belief or the old theory or assumptions are not true, and he want to establish a new claim, then that will come as an alternate hypothesis. That means something new is happening. And generally null hypothesis is denoted by H0, whereas the alternate hypothesis is denoted by HA or H1, right? So again, Alternate hypothesis sometimes also we used to refer that as a researcher hypothesis. So whatever new claim you want to establish will be the part, or a statement will be in the form of alternate hypothesis. So now let us see some of the examples of null and alternate hypothesis to get more clarity. For example, if I believe that there is no relationship between the number of attendance and the marks scored in the exam, and I want to prove that no, there is a relation between the number of lectures which a student attends and the marks he scores in the exam. It might be possible that it may not be the 100% relevant for all the years, but 100% I'm sure that for the first year student, there is a significant impact of however number of lectures he or she has attended and the final exam scores which he or she secures. So here the null hypothesis will be the number of lectures attended by the first year student has no effect on their exam scores. Whereas I want to prove, or researcher want to prove, that number of lectures attended by first year students have a positive effect on their final exam scores. That means it may lead them to score more marks. Let us take another example. In this COVID situation, suppose I want to prove that drug which I have been proposing, that means drug A, is effective for the treatment of COVID-19. So null hypothesis will believe that okay, there is no effect of this new drug on COVID-19 disease. So the null hypothesis will be like drug A for the treatment of COVID-19 is not effective. And wherever the researcher want to prove that it is effective, so that will be the part of alternate hypothesis. Last example, let us say that application of biofertilizer X do not increases the plant growth. Whereas a researcher want to prove that no, application of biofertilizer X will leads to increase in a plant growth or increases the plant growth. Then that will be the part of the alternate hypothesis. So I hope that these examples will give you more clarity about how to frame statistical hypothesis, especially the null and the alternate one. Now let's learn some of the more concept which is very important in this entire process of hypothesis testing as well as the inferential statistics. One term which we came across is estimation. What do we mean by estimation? So generally in this inferential statistic, we used to estimate population parameter with the help of sample statistics. So that process by which one makes inferences about the population based on the information about this obtained from the sample is called estimation. Again, in this process of estimation, we used to undertake two particular estimates, which is called or known as point estimate and interval estimate. So let us learn something more about what do we mean by point estimate and interval estimate. The single value of a statistic calculated from the sample, for example, x bar, is called point estimate. So for example, in a process of estimating population mean, generally we collect the sample and calculate sample mean. And then that will be represented by x bar. So we generally say that this x population mean mu will be approximately equals to x bar. So that point estimate, that means x bar, which we try to estimate that as a population parameter, that will be called point estimate. But how much percent we are sure that exactly the mu value of the population mean will be exactly equals to point estimate, that means sample mean, then we may not be the 100% sure. In sometimes even we may not be the 50% sure that okay, it will be exactly similar to that. But when we ask you that okay, so can you give us a range within which like population parameter will going to be fall, that means plus or minus error in our process of estimation. So that will be the part of interval estimate. So interval estimate is a range of values calculated from sample statistic and standardized statistics such as Z. As you can see here we are trying to estimate about population mean, that is mu. So here we are taking one point as a point estimate x bar, and this interval estimate which is having a lower limit and upper limit, that is plus or minus 5% or plus or minus 10%, will be like these points will be the interval estimate, and we will be having some confidence level that our population parameter which we are trying to estimate may fall within this range. So generally the true population mean which is unknown, we take a sample from the population to estimate about the population mean. This is a point estimate, and these 2 points, right, that means a range of values will consist of interval estimate. So you will get more clarity once we discuss one example. But before that, let us understand, I have referred a confidence. So let us understand what do we mean by confidence level and confidence interval. So first, what is confidence level? It is nothing but a probability which often expressed in percentage is a degree of assurance for an interval to contain a value of parameter. That means a range within which we are a little bit more confident or we assure that the value of population parameter will fall in between that particular range. So from that confidence level, we come across the term called confidence interval, which quantifies the uncertainty in measurements, right? It usually reported, like for example, 95% confidence interval, which that means the range of values within which it can be 95% certain that the true value of the population parameter will going to be lie, right? So with the help of confidence level, we can have a confidence interval. And rest, what about the 5%? That 5% we are just assuming the margin of error, that it might be possible that 5% chances are there that the population parameter may not fall even in this particular interval. So that will be called level of significance, which will be denoted by alpha. The level of significance is the probability of rejecting the null hypothesis when it is to be true. So that's why, like, once we have the alpha, which is just a complement to confidence level, is so if our confidence level is 95%, our alpha will be 5%, or vice versa. If our alpha is 10%, then our confidence level will be 90%. In next slide, I am going to just explain all this concept with the help of one chart. So for example, point estimate is a single number, let's say x bar. Interval means plus or minus range which we are trying to ascertain, where we are a little bit more confident that population parameter will lie, right? So it will be around or in and near about point estimate. So in interval estimate, we have one lower confidence limit. So this is a lower confidence limit, and one upper confidence limit. So this is an upper confidence limit. So here directly by uh, assuming that x bar will be approximately equals to mu, that means population mean, we are trying to estimate that it may fall within this range. So that's how, like, the formula for confidence interval will frame like this: mu is equals to x bar, which is point estimate, plus confidence level, which can be 90%, 95%, 80%, depends on the researcher. So that is a confidence level, which is generally denoted by z, and margin of error, which is sigma upon under root n. So in this diagram, here we can see that we are 90%, here we can see that x bar is 198, and we are 90% confident that population parameter, that means mu, may fall between the range of 192 and 204. So this is the interval estimate, 192 to 204. And what is the confidence level? 90%. So what will be the level of significance? So 10%. So 5% on the left side of the curve and 5% on the right side of the curve. So this range 190 to 204 is known as interval estimate. 198 is called point estimate. What is the confidence level? Okay, 90%. And what is the level of significance? Okay, 10%. So I hope that now you are clear about all these critical terminologies or difficult terminologies, like what is estimation, point estimate, confidence interval, confidence level, and level of significance. Now let's move to the next important concept. So during this process of hypothesis testing, we may commit some kind of errors. So these errors will be classified into two types of error. One is called type 1 error, and second is called type 2 error. So type 1 error means what? Rejecting a true or null hypothesis. That means when your hypothesis is true, but you are rejecting it. That means as an outcome of the experiment, you are rejecting it. That means you have conducted an error which is called type 1 error. Null hypothesis is true and you are rejecting it. Same way, suppose hypothesis is true and you are accepting it, that means you have made the correct decision. Same way, suppose hypothesis is false and you are rejecting it, that means you have made a correct decision. But when your hypothesis, null hypothesis is false, but somehow you are accepting the null hypothesis. That means again you have conducted an error in hypothesis testing, which is called type 2 error, which is generally denoted by beta. So in summary, type 1 error means rejecting a true or null hypothesis, and type 2 error means failing to reject a false or null hypothesis. So which is denoted by alpha and beta respectively. So once you are clear about the type of errors which you commit at the time of hypothesis testing, now let's learn about rejection region, non-rejection region, and one-tail and two-tail test. So during our hypothesis testing, generally we came across like it is a one-tail test or two-tail test. What is that? So it depends on your alternate hypothesis. Like suppose if your alternate hypothesis is just like suppose I'm purchasing a bottle of Coca-Cola, and my assumption is that the quantity which I am getting is 200 ml. If a researcher that wants to prove that no, the quantity is greater than 200 ml, that means rejection region will fall on this particular side, that means right side of the curve. So this will be called a right tail test. Same way, suppose if a customer wants to prove that no, the value is less than 200 ml. That means he wants to prove that it is lesser than the mean value, that means which is 200 ml. So he is interested that he will only going to win if it will fall below than 200. So the rejection rate will fall in this particular side. It is a left tail test. Whereas you just want to prove that it is not 200 ml, irrespective whether it is greater or lesser, it doesn't matter, but it is not 200 ml. Then the rejection region will be on both sides of the mean. That means suppose the mean value is 200 ml, then whether it is greater or lesser, in both the cases you can able to reject the hypothesis. So this is a two-tail test. So the one-tail test or two-tail test or left tail or right tail largely depends on the alternate hypothesis. That means what researcher wants to claim. And accordingly we can decide about the rejection and non-rejection region. Generally the portion which has been shaded in white color is white color is known as non-rejection region, and the portion which has been shaded in red color is known as rejection region. So in case of one-tail test, the rejection region will be on the either right side or left side, depends on the alternate hypothesis. In two-tail test, generally the rejection region will be on the both side of the tail. Same thing has been explained in the next slide. Here, let's assume that this is a confidence interval. So if your test statistics will fall in this range within these two critical values, then you are not going to reject the null hypothesis. Do not reject the H0. This is called non-rejection region. But if your test statistic is above this particular critical value or below this particular critical value, then you are going to reject the hypothesis. So in this case, the critical values of Z score is minus 1.96 and plus 1.96, which is over and above the mean value, or in Z score it is 0. So this is a 95% confidence interval, and the 5% is the level of significance. Because it is a two-tail test, so we have divided alpha, which is called level of significance, divided by 2. So 2.5% on the right side and 2.5% on the left side. In case of one-tail test, we do not divide the alpha. That means entire rejection region will be on the same side. So that means we have taken entire 5% on the right side, and similarly the value of the Z also changes. And this entire 95% will be known as do not reject region or non-rejection region. So I hope that this important concepts of which we often refer in inferential statistics is now clear to all of you. If you have any query, then please drop me an email on my email ID chintan.rajan@rq.se.in. In next session, we are going to take one example and discuss about the entire process of hypothesis testing. Thank you.